Hello, everyone, and welcome back. We're so excited to have you all here today for our first keynote of day 2 of PsyAccess 2021. I have the distinct pleasure of introducing you all to our distinguished keynote speaker, Joshua Miele. Joshua is a 2021 MacArthur Fellow. The MacArthur Fellowship, known to many as the Genius Grant, is a prize awarded annually to individuals who have shown extraordinary originality and dedication in their creative pursuits and a marked capacity for self-direction. Joshua is an blind adaptive technology designer developing devices to enable blind and visually impaired people to use technologies that pervade our lives. Joshua's graduate work focused on psychoacoustics and directional aspects of hearing. More recently, he is creating effective and affordable solutions to everyday problems blind people face, with a particular focus on access to digital information. One such solution that Joshua developed is Tactile Maps Automated Production, or TMAP, a web-based software that generates tactile street maps of any location that can be printed with an at-home Braille embosser. Using this software, Joshua has designed a set of tactile maps for every station in the Bay Area rapid transit system. Currently, Joshua is an accessibility researcher at Amazon, where he has contributed to projects such as Braille compatibility with Fire tablets and a show and tell feature on camera-enabled Echo devices that can identify pantry and food items. Joshua's expertise in information accessibility and his commitment to making solutions available for mass use will be increasingly important as we move into an even more digitalized world. Joshua, thank you so much for being here with us today.
It is my pleasure. I am so thrilled to be here. Thank you for such a warm welcome and nice introduction. I'm going to double check my camera with you again. Anna, looking okay? Everything
yes.
Cool?
Looks great.
All right. That's great. Hey, everybody. This is like so exciting to be joining PsyAccess. And, you know, normally for a presentation like this, there's the sort of the room and, the people in it, and you can feel the excitement from everybody having, been through a day and a half of PsyAccess and like all the cool stuff that's been talking. But I'm sort of talking in my own office, which is, kind of a weird thing. But I guess we've all gotten sort of used to doing this sort of thing. But I do miss being in a room with all of y'all. I've been asked to give myself a little introduction. So my name is Josh Miele. I use he, him pronouns, and I've been also asked to give a visual description of myself. I have mixed feelings about this visual description practice, but I'm not going to take it out on you. As a blind person, I don't usually care that much about what people look like. I care much more about their identities and how they identify and what they the work that they do. But I do recognize that the visuals are kind of interesting and at some level important. So to describe they told me that I should describe myself as an Asian man sitting in front of a Star Trek Enterprise backdrop, but no, I'm just kidding. That was just the example that they provided. I am a one-eyed, burned, blind guy, and I present as fairly white. In fact, I don't know what that means, but that's who I am. And a lot of people go into all of this stuff about what their background is and what the books are on their shelves and how messy their office is. And I think most people, when they are asked to do a self-description, they tend to focus on the things that no sighted person would even notice. It's hard to know what to tell people about yourself. So, but this whole sort of hour that we have in front of us, I'm actually going to be telling you quite a bit about myself and sort of how I came to be talking to you today about science accessibility, STEM accessibility, and space, which has been a huge theme in this conference: space access and equity and equality of people with disabilities having having access to or opportunities in space-related fields. So rather than telling you what my office looks like, I'm going to tell you what I'm going to tell you. So I'm going to try to weave together some themes about STEM accessibility, which I've been working in for actually, maybe only 5 or 6 years, and also sort of how I got to how I came from a young person being obsessed with STEM and science and math, and thinking that I was going to be a space scientist. I was really excited about studying space and planetary physics and astrophysics and astronomy and spacecraft design. All of those things were fascinating to me as a child and as a young adult. And how I came to instead be an accessibility expert of some kind. And along the way, I'm going to talk a lot about disability identity and blind identity, and how disability and accessibility and STEM and self-determination all fit together, at least in my story. And we all have different stories. So I'm going to start out with a little bit of stuff about about the Blind Arduino project, which I've been involved with and helped start since about 2015, 2016. So as many of you probably know, Arduino is a hobby robotics platform that's used in lots of educational, scientific, and hobby robotics applications. It's a microprocessor that can be used to control and manage all sorts of fairly complex electronics projects. You can connect up motors and lights and switches and sensors and all kinds of stuff, and it's pretty easy to use. It's pretty easy to access, and I've been sort of involved with the Blind Arduino project because I see it as a really a holistic representation of how accessibility and STEM fit together. Because it's not just about teaching blind and visually impaired people how to use these tools, because that's just part of it. It's about teaching people who are sighted that blind people can use these tools. And it's about teaching blind people how to use these tools, not just to learn and participate in STEM in education, but how to build the devices that they need for accessibility that you simply can't buy off of the shelf. And it's also about helping young blind people participate equitably and equally in STEM education opportunities, so that when they get to middle school, high school, college, they have the same sort of hands-on experiential learning background as their sighted peers. And not only that, but their sighted peers hopefully have a background working with blind and visually impaired people. And so when those cohorts, the blind and the sighted folks from who've been working together, go into these STEM fields, it is no longer remarkable for blind people to be inventing, designing, building things with electronics. It's just sort of the way it is. And that's the societal change that we're after. But I'll say a little bit more about that in a minute. For now, what I'm going to tell you is that all along the way, as a person with a disability, one always is in a position of having to figure out how to do the thing that you want to do. It's not designed for you. It's not quite set up for your participation, but with a little bit of ingenuity, with a little bit of creativity, with a little bit of effort, extra effort, I will say, because we're always in a position of having to do more in order to participate. And that's not the way it should be, but that is the way it is. But necessity being the mother of invention, as we have been taught, it is always sort of upon us to invent how we're going to do the things that we want to do. And that has been a theme throughout my life. As a child, being, as a blind kid, being fascinated with STEM and electricity and electronics and science and math in general, so much stuff needed to be figured out about how I would learn these things. My, there was a thing called Heathkit when I was young, and these were kits that you could buy and build yourself, and they were, electronics things. I built a burglar alarm when I was, 10, and I built lots of doorbells and lots of various sort of systems that would make noise and do things. And I did them because I would conscript other people who didn't want to, who didn't necessarily know that much more than I did, but they could see and they could read the directions. It's really easy. Like I can build most IKEA stuff myself without looking at the directions, because you take it out of the box, you look at the parts, you know what the thing is supposed to be in the end, and it takes a while longer, but it's like building, it's like a puzzle, right? You've got the pieces, you know what it's supposed to look like, and eventually you assemble it, and you've got a couple of extra washers at the end, and maybe some screws and pegs left over, but you've essentially got your bookshelf. It's a lot harder to do that with electronics. So reading the directions was really helpful. So I would make my mom read me the directions. I was nervous about soldering as a child, so I would have her do the soldering. And by the way, I now teach, as part of the Blind Arduino project, I teach soldering workshops for blind people. So that's I'm no longer nervous about that, and nobody else should be either. But it was about figuring out how to do it, right? It was about figuring out how to make this happen as a child. And this sort of continued to be a theme, of course, throughout, as a blind person, you need to keep figuring stuff out as you learn and grow. There continue to be new situations that you haven't come across before, and that, as a child, by the way, we didn't have the internet. I'm 52. We didn't have the internet until about effectively 1992 or 3. So it was really hard to find the information you needed. You couldn't just Google, blind soldering and find 50 people who knew how to do it, and a whole, compendium of tips on how to do it. You needed to either figure it out yourself, or you needed to have someone in your network that could teach you how to do it. And that gets to another thing. I mentioned, having people in your network, and that's one of the areas. Although growing up, I did, attend a blind summer camp, and I did, certainly have some contact with blind adults. I really didn't think of myself as being a blind person. I thought of myself as being fairly unique, because all of the blind people I knew about were, kind of, a little bit behind the curve, a little bit tentative, a little bit nervous about things, a little bit, sort of not as bold and out there as I wanted blind people myself to be. And so I thought I was alone. I thought I was sort of unique in being kind of a blind person who just wanted to do things. And I can't tell you, sort of what a mistake that was, but it's true. And so there was this sort of internalized ableism that I had as a child. And ableism is one of these things that, maybe we've I think many of us are thinking about these days. And certainly internalized ableism is one of these areas that not only keeps us from sort of achieving, but can often keep us from community that can help connect us with the knowledge and background and skills and sort of institutional smarts to not have to reinvent wheels. So, and it wasn't until I got to college that I discovered that there was a whole world of cool blind people out there, and that they were just as capable and just as cool and just as interested in things as I was, and that in fact it was cool to be blind, and there were things that we were doing that other people weren't doing, that that were challenging and interesting and worth taking pride in as blind people. And that really changed the way I looked at disability. I grew up in New York. I grew up in the suburbs of New York, where not only were there not any blind people, but there weren't any sidewalks and there wasn't any public transportation. I can't imagine why there weren't any blind people there, but there it is. So, but once I got to Berkeley as an undergrad, I realized that I met just a slew of people with disabilities and blind people, and this was in the late '80s, when the disability rights movement had really been extremely powerful in Berkeley and in the Bay Area, and in a number of other locations as well in the 1970s and early 80s. And it was still in the air when I got to Berkeley. And I realized that I was a person with a disability. I was blind, and it was something to be proud of, and that there was a whole community of people out there who were part of this identity, who took pride in being disabled, being blind, being deaf, being using wheelchairs, all of these things. And it was completely revelatory to me as a young person. And I think this is not a unique experience. Lots of young people going to college find their people. They find their identity for the first time. And that happened to me, finding a blind identity and people I really loved and respected and could learn from, who were blind, who were deaf, who used wheelchairs, who were deeply experienced in the disability rights movement and the disability culture movement, and who were thinking about disability not as something to be sort of swept under the rug and minimized, but as something to be held up as a centerpiece of identity. And I want to, if you are not there yet with embracing disability as an identity, I want to encourage you to think about that and think about why you aren't there yet, because to hold disability as a core part of your identity is if you are disabled. I mean, I'm not saying everybody should do that. If you don't have a disability, then by all means put other things at the center of your identity. So these are all part of the disability and design story that I'm trying to tell you, because although I was so I came to Berkeley as a physics student. I wanted to study. I did study. I graduated from Berkeley with a BA in physics, and I wanted to study physics. I wanted to work at NASA. I wanted to build spacecraft and explore the planets in our solar system and the properties of our star, and understand, learn more about the universe in which we live by studying the solar system. And I took lots of classes on I took a great class at Berkeley where we designed our own spacecraft. I designed a solar sail, a spacecraft that would use solar sails, and I learned all about solar sailing in that class. Really cool. And I did get an internship at NASA. I worked at NASA for 6 months in 1992-93 at Goddard Space Flight Center, and it was a wonderful, incredible experience. I was, again, the only blind person there, but by this time I had, sort of understood more about who I was as a blind person. Was very excited about being an intern at NASA. And our project was, I was working on a spacecraft called the Mars Observer, which was launched in the mid 80s and was started to design in the mid 80s, was launched in the early 90s, and was on its way to Mars when I was an intern. And part of what I was doing at Goddard was to write software for one of the instruments on board this spacecraft that would, it was an interferometer that was intended to look at different layers of the atmosphere, measure temperature at different levels in the atmosphere, and really sort of do some learning and measurement of atmospheric properties on Mars as a function of height. And so I was actually like writing software that was going to be used to interpret and measure this data. And while I was there, the spacecraft was supposed to arrive at Mars, and it did. It was in a solar orbit. Around, if I was a sighted person, I probably would have done up some slides for you about this. But in solidarity with keeping my presentation as accessible as possible, I was like, no, I'm not going to do any slides. So besides, I hate doing slides. But the Mars Observer basically was in a solar orbit. It was in orbit around the sun as it got from Earth to Mars. And then once it gets to Mars, what you do is you give it a little kick. You power up your thrusters and you push it into Mars orbit if you've done all of your planning right. And so we pressurized the propellant tanks, and we never heard from the probe again. Probably what happened was something went wrong with the tanks, and as one of my mentors put it, we know where its center of mass is, but we don't know where it is. So that was a very tough moment to be on a team at NASA. It was really interesting to sort of see that science is not just sort of success, but that failure and setback is always part of the scientific process. It's always part of learning. And so, yes, there were, we've sent lots of probes since then, but my contribution to science was not to be in that area. I think I was like maybe a junior at that time, and I was also working at the same prior to going to NASA, and sort of and subsequently, I was working at a small software company in Berkeley called Berkeley Systems, which was one of the first companies. It was a little software startup, and the old timers in the crowd may remember the fish tanks, the screensaver called After Dark. Berkeley Systems also made a screensaver, which was wildly popular, which is where we got lots of our bread and butter. But it was actually started as an accessibility company, and the accessibility tools that we made were the first screen reader for a graphical computer. We made a thing called Outspoken, which was a screen reader for the Mac, and it was released in 1989 and was really revolutionary. At that time, blind people thought that with the advent of graphical computers moving away from command line interfaces, that we were going to be left out of the computer revolution that was happening, and people were very justifiably terrified that all the great programming jobs, all of the great computer-related jobs that blind people had been able to get into in the 70s and 80s were going to be lost, because suddenly computers were no longer text-based. They were icons and graphics and dragging, clicking and dragging and all the rest of it. So the company that I was working for, Berkeley Systems, was a company that made the very first screen reader that could deal with this graphical environment. I'm going to take a quick minute just in case screen readers need an explanation, but it's a piece of software that lets blind people interact with just a standard off-the-shelf computer. iPhones have screen readers built in nowadays. Windows computers have sort of a kind of a mini screen reader built into them, but you can install a real screen reader if you want. A Mac, Mac computers have a screen reader built into them. So, and Android phones do it as well. So screen readers are now sort of part of the fairly standard landscape, but they weren't back then. And so in doing this work at NASA, and in doing the my undergraduate physics degree, and in working at Berkeley Systems, I started sort of pivoting. In my early days, I had been, fairly adamant that I didn't want to go into accessibility. I didn't want to go into a blind field. I didn't want to do something blind. I wanted to be out there in the quote unquote real world, participating in real things. And so I wanted, the idea of working at NASA was very attractive. And also in doing these things that I wanted to do, the physics degree, the working at NASA, I continued to have to invent the things that I needed in order to do the things I wanted to do. I had to write my own scripts that would present information accessibly to manage Linux or Unix computers at the time. I had to design tactile graphics software that would let me print out my data when I was working at the on the Mars Observer and before that. I had to develop systems where, when I was working in for example, a semiconductors lab as part of my undergrad degree, I had to sort of develop how I would, because we didn't have any accessible instruments, we didn't have an accessible, oscilloscope or anything like that. So I had to work with a partner, and I had to develop all of these systems, which were how am I going to work equitably with a partner that's not the partner doing all of the work, and so again, all of these things needed to be sort of figured out, and so in working at Berkeley Systems, and I was just, I wasn't doing fancy stuff there. I was writing documentation. I was doing technical support. I was helping in some small measure at the time. I was helping to sort of design features and interface elements, and how what we've now called behavior, how the screen reader would behave under certain circumstances, and we would also go to a lot of conferences. The Berkeley Systems crew. We would go to blind conferences, we would go to disability conferences to show our screen reader. And in going to these conferences, I realized that a lot of the people that were doing the deep thinking and the sort of most prominent talking about accessibility and accessibility design were sighted people. They were people who didn't have disabilities. They were people who had PhDs, who had done a lot of thinking about computer-human interfaces, but they weren't blind. And having grown up as a blind person, I knew that there were a lot of technologies out there designed by sighted people that didn't really do the things we needed done. And so I realized sort of in this evolution, the other part of sort of the NASA revelation, I was a student at UC Berkeley. UC Berkeley is a gigantic public school, wonderful place. I completely love it. I did my undergraduate and graduate degrees there, but it is a huge place, which is part of why I love it. An enormous bureaucracy. And when I went to work for NASA, I realized that that I didn't know anything about bureaucracy, and that these federal government people really knew how to do bureaucracy in a way that was, you know, they knew how to take it to scale. And there was also the sad part about the Mars Observer breaking. And so I kind of realized, I had a revelation at the time that that I could be a physicist, I could be a scientist, I could go into some physics or science thing, I could go to grad school for physics, but I wasn't a brilliant physicist. I didn't have a lot to contribute in the area of physics. And there are probably millions of people in the world who do have a lot to contribute in physics. But I realized that that I did have something really really special to contribute in accessibility, in that I am a blind person who has been doing a lot of deep thinking about how our tools should behave. What kinds of tools do we need, and what features do they need to include? What are the design parameters and requirements for the tools that we use in order to get the things we, you know, have access to the things we want to do? And I realized that that in fact I would be better at I would be making a bigger contribution by building a career in accessibility than I would if I built a career in physics. And at the same time, I didn't at all feel like I was settling. I felt like I was sort of realizing where I could do the most good. Because as a blind person, I do understand how to design the tools we need. I do have a very specific kind of insight into the requirements for how to build screen readers, how to build you know, other tools that I'll maybe talk about that I sort of developed subsequently over the course of my career. And I think that you know, Anna mentioned the MacArthur Fellowship when she introduced me. This is still very new. I'm just getting used to it, but the MacArthur Fellowship is an interesting position. They one of the most important criteria for receiving one of these fellowships is creativity in the work that you do. And I think that one of the things that's most important about the way I approach accessibility is that I think of it as a creative design challenge rather than as a checklist. Certainly, checklists are useful. Checklists, you know, to make sure that you're getting everything you need to do. But in order to do really good, high quality design of something, you need to have a deep understanding of it, and And you need to approach each new solution, each new problem as a creativity, an exercise in creativity. And so that's how I approached screen reader design when I was working at Berkeley Systems. I eventually, I continued to work at Berkeley Systems for a number of years, and I continued to, grow in my role there, and eventually was doing a lot of the design work of how the next generation screen readers would work, because we moved, at that time, Microsoft Windows was coming out. We were designing Outspoken for Microsoft Windows, and so part of what I was doing was designing the features and the educational tools that we needed for that. And for example, one of the things that I realized in that process as a blind designer was that it's not enough to just design the tools. You need to design the tools that will teach the user about these sort of unique things. So one of the things that we included that was my one of my babies, and we included these with I didn't invent this. I just sort of made sure that it happened. But the idea of a graphical interface with dialog boxes and buttons and windows and menus is something that needs to be communicated clearly to a blind user, because when you're using these interface elements as metaphors for sort of how to interact with your applications, you really need to understand kind of what it looks like. And when I say looks, I mean really the spatial layout and how it happens. So we included tactile graphics and Braille labeled tactile graphics with our documentation, and it was a very powerful tool for helping people learn what not only how to use their new graphical screen reader, but how to use this crazy Windows environment that nobody was yet accustomed to. Now it's sort of second nature to almost everybody, but at the time it was very difficult for people to wrap their minds around. So that's an example of the kind of creativity that is necessary in thinking about accessibility. It's not enough to just sort of check the boxes. It's really essential to think deeply about who's going to be using it, what they're going to be using it for, what are the other things that they do, what are the other constraints and requirements that they have, and how is this tool that you're designing and building for them going to fit into their workflow, their day, and how is it going to be not just usable, but usable easily and dare I say, delightful to use. So that's what I've been after since that time, is to design these things. And I mentioned, the sighted people doing sort of calling the shots that I noticed. And so I realized that if I wanted to be one of these people calling the shots, and not just a blind guy who thought he knew how to design stuff, I needed to sort of up my game. So I went back to school. By the way, I've always been obsessed with STEM. I've always been obsessed with learning. I love learning, but I've kind of always hated school from the very beginning up through the very last moment of my PhD work. That's not to say that you should hate school or that others should, but it's to say you can get through it. Hopefully, it is doable. School is a process, and a lot of the time, to me, it felt like I wasn't doing anything. I wasn't making anything that would be useful to anyone. Writing a paper for a class is useful only to me to learn the stuff. It's not actually doing anything at the same time. I love to learn by building stuff, and also to build stuff that might be useful in the long run, to at least to me and maybe to other people as well. And that's how I've done most of the real learning in my life, is sort of learning by doing and hopefully making something useful in the process. So I did decide to go back and get a PhD in order to up my game. And the PhD is in something called psychoacoustics, which is how hearing works. And there's lots of different aspects to psychoacoustics, but I was really interested in designing computer interfaces that would take advantage of spatial hearing, 3D sound and location using binaural listening, and that's something that so I spent a good 6 years of my life studying it, and I use it once in a while. But the main thing I learned in grad school is actually how to design good experiments, and good experiments are really essential when you're designing tools, because you want to know whether or not what you're doing works for people. I am blind. I design stuff for blind people, but that's not enough. Any designer, any good designer knows that if you're designing something for more than just yourself, that you need to make sure that you need to validate your assumptions. You need to check whether or not things are working for other people. And I do have a great, I live in the blind community. I know a lot of blind people with a wide range of capabilities. So I'm starting from a good position, but I always do research to understand how the tools that I'm developing work for the people that I'm designing them for, the rest of the blind world. And that's really important, because obviously, I am an N of one, as they say. You don't want to design stuff just for yourself. That's so I learned how to do really good research in grad school, and I brought that subsequently to my work at Smith Kettlewell, where Smith Kettlewell Eye Research Institute, where I was for 20 years, and I designed, as was mentioned earlier, the tactile maps that the TMAP, which now lives at the San Francisco Lighthouse. Anybody who wants a street map of anywhere in the world can order one from the Lighthouse or sign up to use their TMAP website and can download and print out a street map of anywhere you want. And that's something I designed because I wanted it, but I knew that it was needed. And I did a lot of evaluation and testing to make sure that it worked for others. I also did, at Smith Kettlewell, designed and created a thing called YouDescribe, which is a tool that allows anybody anywhere to add audio description to any YouTube video and share that with the world, which is a really sort of creative, and if I do say so myself, it's not just a tool that people can use. It's a tool that challenges how people think about accessibility and what audio description is and should be and could be, because it allows experimentation with audio description, and it allows feedback about audio description. So these are the kinds of tools that I like to make. I like to make things that challenge, that provide functionality, that provide support for helping blind people do the things they want to do, and also which help people think and ask questions of themselves and others about accessibility and equity. So I started talking about space, and how I wanted to be a space scientist, and I'm going to come back to that. One of the things that I think is most interesting and most challenging, and I think that some people have spoken about this at SciAccess, is the idea that astronauts need to be, fully able-bodied, as it were, and that unless you have a body that's perfect, it's too dangerous for you to go into space. And I'm I'm interested in, I challenge that. And I also am of the opinion that if we are, as a species, going to go into space, we're going to be out there for a while, and space is a dangerous place. And even if you do send your most able-bodied people into space, eventually they're gonna become people with disabilities. They're going to acquire disabilities in space. And if we don't design our systems, our environmental control systems, our spacecraft control systems, and the rest of it, if we don't design those systems so that anybody can use them, blind people, deaf people, people with limited dexterity, we are going to be in a serious pickle when people in space acquire disabilities. And that leads me back to, if we are going to design our systems for anybody to use, why not let anybody go if they are qualified in other respects? And so it's really, again, I invite you to think about those questions. And right now, as Anna mentioned, my current role is as a designer or researcher at Amazon, where I'm working on accessibility stuff for for Amazon's devices, tablets, Alexa devices, etc. But eventually, one of the things that I would love to do is think deeply and help design what our spacecraft control systems are going to look like when they are accessible. And so that's how my story, I'm gonna sort of end on that. My story comes full circle from wanting to be wanting to do space science through accessibility and disability identity and back to space. And I wanna say again, what an amazing conference this is, and what a pleasure it has been to speak to you today. Anna tells me that we're gonna have some time for Q&A, and I'm really excited to hear from you about what questions and thoughts my remarks have provoked.
Absolutely. Thank you so much, Josh. We really appreciate that. And we'd love to now open it up to questions from our audience. So as a reminder, please feel free to type your questions in the Q&A or to use the raise hand icon if you'd prefer to ask your question out loud. So with that, we'll go ahead and jump in. Our first question for you is from Anali, who says, "Thank you for sharing your ideas with us. I was wondering where we could find the audio describing tool."
Oh, it's at youdescribe.org. YouDescribe, YOUDESCRIBE.org. And it's still, I'm no longer sort of on the project, but it's still being maintained by Smith Kettlewell. It is being used by thousands of people all over the world for education, primarily for education. A lot of TVIs and teachers use it to describe videos for blind students. But it's also being used by people just for fun, and also for workplace accessibility. Lots of stuff being described there. I will, quite candidly, there are some rough edges, particularly on the authoring tool. But it's a really cool experience, and I encourage folks to check it out. There's also an iOS app that doesn't allow you to author audio description, but it does allow you to view YouDescribe content.
Fantastic, thank you. And our tech team just shared that link in the chat as well, so you can go check it out there. Next up, I see a raised hand from Zuby. So Zuby, if you'd like, I've just enabled your audio access, so you can go ahead and unmute your microphone and ask away.
Hi, Joshua. Thanks so much for sharing about your knowledge and experience with us here at SciAccess, and huge congrats on your Genius Award.
Thank you.
Question is, how can more blind and disabled people win the Genius Award? But really, the follow-up question, is, how can we encourage more blind and disabled innovators? How can we clone more Joshuas, more Chieko Asakawas, more Vince Cerfs? And what are the incentives to get them to start creating technology solutions, both for the disabled and everybody else?
Great question. And there is no one answer. It's a constellation of things that we can do. But I think that the most important, I decided to pivot into accessibility because it was where I could contribute the most, I think. But one of the things that I think that the most important thing is to get students access to information early. And this is one of the things that I had thought about talking about. And in 45 minutes you can only cover so many things. But one of the accessibility is only part of inclusion. Accessibility is the technical side of inclusion, and you can make all kinds of things accessible, but the cultural side of inclusion is really key. And the more people sort of see, as it were, that blind people can achieve, the more readily people will be ready to support blind achievement. The thing that holds us back, for the most part, is ableism. Teachers and parents and society sort of assuming that blind people cannot achieve, and sort of creating low expectations among people who are blind. And that's the biggest problem. Accessibility is like, it's a technical problem. It's kind of easy to solve. The harder problem is the social dynamics. So I think that the more we work on getting students to succeed, blind students to succeed early, and to believe in their hearts that they can do whatever they want, even though they are blind, the more likely we are to see more blind people sort of achieving at the highest levels. And but blind people shouldn't. One of the things that I like to remind people is that blind people don't have to, like, just because there are blind people achieving at the highest levels doesn't mean that every blind person has to shoot for that, right? Like some people just want to be regular people, and that's okay too, right? But you shouldn't have to do that. Just, you shouldn't settle for having an insurance job because that's the only avenue open to you. You should do that because that's what you want to do. And sort of designing, trying to shape our educational system and the support systems that we have for blind kids and young adults is really that's what's going to have the impact on blind people's ability to do whatever they want to do, whether it's high achieving or low achieving, or middle achieving, right? But it shouldn't be because you can't. It should be because you don't want to, or you've got some other plan. And I could spend a lot more time answering your question, but I think I'll leave it at that and see if we've got more questions.
Thanks so much, Joshua. I appreciate it.
Thank you.
Next, I'll call on Agrios, who has his hand raised. So feel free to go ahead and unmute.
Hello.
Hello, Agrios.
Thank you very much for the inspiring talk. I'm still living the dream of being an astronomer and probably astronaut and writing code for solar orbiter mission of European Space Agency. So it was really, I really identified with what you're saying. I'd like to ask you, so what is your daily life now? What do you do? You go to the office? What is the tools you use to design the tools that will probably
Sure.
change your life to better?
Well, I don't go to the office these days because of COVID-19. I live in Berkeley, California, and I have 2 kids and a wife, and my kids are sort of older teenagers, and the tools that I use for work are I have a Braille embosser that I use mostly for graphics, and I use NVDA as a screen reader on Windows. I use a Braille display, and I do a lot of writing. Design. We often think of design as sort of drafting, drawing wireframes or whatever. But a lot of the design work that I do is through writing documents and describing experiences. And when I was I also, if there is a need to do any kind of drawing, I sometimes use a tool called OpenSCAD, which is a command line based 3D modeling program. So you can actually use text-based code to design 3D objects or 2D objects. So I use it for both. I use SVG if I need to render graphics for folks who can see. I use a cane in my life to get around. I think those are the tools that I use. I'm a big just for sort of to round out my the picture. I did when I was in college. I actually used I had a guide dog. It was interesting because I didn't have the context of blind people. I assumed that when you go to college, you're supposed to get a dog because that's what all the the movies showed. So I got a guide dog when I went to college, and realized very quickly that that all of the blind people that were the most independent, that were doing all of the things that I wanted to do and could do, were mostly cane users. So I used a guide dog for about 3 years, and then I gave the dog back to the guide school, and they reassigned him. Not because I didn't love the dog, but because I felt more independent using a cane. And but I do, one of the things that I really appreciate about that experience is that now I actually I can understand the blind mobility experience from both sides, and am capable of, that helps me when I'm designing tools like Over There, which was an iOS app that I created for wayfinding. It was a GPS app. It's no longer available, but maybe again someday. Just thinking about how everybody gets around, whether they use a cane or a dog, very useful to have a broad experience in order to think about how to design tools for everyone.
What was the first device you mentioned about graphics?
I have a Braille embosser, which is a Braille printer. So Braille is basically created by poking holes in paper. A Braille graphics is created by poking lots and lots of little dots very close together through the paper. It's sort of like a dot matrix printer, but that you can feel the dots instead of ink.
Okay, should we wait for should we hear from a smart cane from Amazon then?
No, and we don't have a lot of time left, but I'm not a big believer in smart canes. The cane is actually an incredible tool as it is. And the more fancy, the more expensive, and the more delicate you make the cane, the less useful it is. I'm not opposed to other supplemental tools for wayfinding. I think that, obstacle detection and, camera-based tools are a great idea, but do not build them onto the cane. You can build them as wearables, build them as something else, but don't put them on the cane, because the cane is already kind of optimal, and anything you add to it is just going to detract from its effectiveness. Anna, looks like we're kind of at time.
Yes, we are. So I want to say thank you so much, Josh. To ask one last thing to end on, do you have any advice for any of the blind students listening in today who might want to pursue careers in science or technology? Any parting words you would leave with them from your experiences?
Yes, I would say learn, use Braille and use tactile graphics as much as possible. Learn. If you're not comfortable with Braille, that's okay. Braille is a tool and a system, and even if you're not perfect at it, it's not necessary to be able to read novels in Braille. It's okay if you're not comfortable with that, but it's very important to be able to read equations in Braille. And similarly, if you're going to be coding, if you're going to be writing computer code, Braille is extremely useful. It's very difficult to be an effective blind programmer using only speech. It can be done, but it's very challenging. And Braille is really useful in making sure that you've got your commas, your semicolons, and to match your brackets. I'll also just say that Braille is although there are lots of rules about how to write Braille, I break them all the time. When I'm writing Braille for myself, I worry about being able to read it myself, not that other people need to be able to read it. When I was studying physics at Berkeley, I basically created an entire code for myself to be able to study physics that was optimized and simple for the stuff that I needed to do, because only I needed to read it. And I don't think that enough people realize that Braille is, it's a system of 6 dots that you can kind of use the way you need to use it. And too many people, I think, are held back by the idea that they don't read fast enough or don't know the code well enough. But being able to use Braille as a tool for literacy, to be able to write down your own equations and read them and think about them. And similarly, tactile graphics, to be able to be tactile, to be comfortable reading and feeling tactile diagrams is really valuable. To be able to represent spatial information in tactile form is extraordinarily helpful in analyzing data and in lots of other situations as well. So that's my advice. Don't be afraid of Braille. Use it as a tool. Don't let it scare you, and don't be intimidated by it.
Thank you so much. And thank you for taking the time to share with us your experiences today. We're so honored to have you here.
It has been such a pleasure. Thank you for the invitation and the opportunity to share my thoughts. And of course, if anybody wants to reach out to me, Anna knows where to find me and can pass along your questions or other things. Thank you so much, Anna, and thank you, Sherry, for arranging for this.
Absolutely. Yes, I would like to say a special shout out to Dr. Sherry Wells Jensen for all of her support and for connecting us. So thank you so much for being here.